Hello and welcome to Understanding Circles and Angles. In this session we're going to look at the basics. This will cover the new curriculum that starts in September of this year, and it'll give everybody a better understanding of how angles and circles work. First thing we're going to look at the basic characteristics of a circle. This is most important when going forward when working with angles. Right, the first part here we're going to look at is the circumference. And that is a distance around the outside of the circle. It's also known as a perimeter. The diameter is simply a point right through the middle of the circle from edge to edge. And then finally we have the radius. The radius is the distance from the centre to the edge. And you may notice that the radius is actually half the diameter. So sometimes in question it may mention the diameter and you have to work out the radius. You simply divide it by 2. Let's look at calculating the perimeter. We're going to look at perimeter area and volume of a circle now. So let's look at calculating the perimeter. And this is done at level 1. And you'll see there this little formula comes up when calculating the perimeter. This is simply a Bodmer's formula. All that means is these are occurrences. So these are symbols and letters, and you cannot work in letters, you have to convert them to numbers. So that little symbol just simply means pi, and the D simply means diameter. Alright, and if you're going on your Bodmer's formula, it's just simply 3.14 times 5. Now there's your 5, because that's the diameter, and the 3.14 is pi, but you have to remember when you look at your exam paper, check to see the value of pi is 3.14 because sometimes they change this. It could be 3, it could be 3.12, it depends on the question. So make sure you read it. And your answer is simply 15.7 metres. And that's all the way around there. Next thing, let's look at calculating the area of a circle. And again, here's your Bodmer's formula. Simply pi times r squared, or radius squared, and that's what it means. Alright, and you see how I do the workings. There's your Bodmer's formula. This is just 3.14 times, and then radius squared. Radius, when you square something, there's your radius there. When you square it, you simply multiply it by itself. So it's 2.5 times 2.5. Now you need to get rid of the brackets because this is a Bodmer's formula, and if you follow the Bodmer's rule, brackets must go first. So 2.5 times 2.5 equals 6.25, and then it becomes straightforward left to right calculation. 3.14 times 6.25 equals 19.625 metres squared. Now remember, you're squaring something off, you've got 2 dimensions, so you must put your little 2 in. If you don't put that 2 in your exam, you will lose points. Let's look at the volume. Now we've already worked out the area of the circle. This is this part here. All you're doing with volume is the exact same formula as area. You're just adding a third dimension, in this case the depth of the height, which is 10 metres. And you'll see in the formula, it's a Bodmer's formula, the exact same. So it's pi times radius squared, and there's your third dimension, you're adding that height to it. This is great when you're working out volumes of pools of water or cylinders or tanks. This is how you do it. So all that formula means is pi times radius squared times height, and you'll see now how I've converted it into a Bodmer's formula. So it's 3.4 times brackets 2.5 times 2.5, just like the area, and now you're adding your third dimension, 10, which is your 10 metres in height. Now, once you get rid of the brackets, 2.5 times 2.5 equals 6.25. You get rid of the brackets. It then becomes a straightforward left to right calculation, and that equals 196.25 metres cubed. So let Bodmer's be your saviour when it comes to doing volume, area, and perimeter. Now let's have a look at angles and the basis of angles. Now we've already established the circumference or the perimeter around the edge. Well, that is 360 degrees when it comes to angles. So the distance from the start all the way around to the starting point again, to the end point, is your circumference, and that's 360 degrees. Now the first angle we're going to look at is something called a right angle. And you can see a right angle here is just a corner. Wherever a corner is, that's a right angle. And you'll see that in squares and all sorts of places. Well, the right angle is actually 90 degrees, because if you look at it logically, that's a quarter of the circle. Therefore, a quarter of 360 is 90 degrees. It's as simple as that. That's how you remember it. Let's move on. Let's look at different types of angles now. The first angle we're going to look at is an acute angle, and you can see by this little symbol, this is how it's expressed. With the right angle it's a square, but it's a little semicircle like that. That tells you it's an acute angle. It's less than 90 degrees. The next angle is an obtuse angle, and this is greater than 90 degrees, but less than 180. So if you go from your starting point to here all the way around, this angle from there to there is an obtuse angle. And the third type of angle that you're going to face, you could face an exam, is a reflex angle. And this is an angle that's greater than 180 degrees. And if you remember from your characteristics of a circle, the diameter is a point. From edge to edge all the way through, and that is 180 degrees. But you can see this angle here is greater than the diameter, so therefore it's more than 180 degrees, and that's a reflex angle. Let's have a look at some triangles now. Triangles is where mostly you'll see a lot of angles, or you'll be asked to calculate a lot of angles. So let's have a look at this first angle here. This is an equilateral triangle. This means all the sides are the same size. And when all the sides are the same size, that must mean all the angles are the same size. And if you see from this note down here, all the sides of any triangle must add up to 180 degrees. Alright, so in this equilateral triangle where the sides are all the same, then the angles are all the same. And that's an equilateral triangle. Let's have a look at some more triangles. This triangle here is called an isosceles triangle. An isosceles triangle just means that these two sides are the same size. You'll always get at least two sides in an isosceles triangle the same size. So let's think about how you calculate. Now remember what it says, all triangles must add up to 180. So therefore simply, if that is equal sides, that means that's 75, so that must be 75, this side. So if you add 75 and 75 together, that gives you 150. And if you take 150 away from 180, that means that this angle must be 30 degrees. Let's have a look at the next angle. This is a right angle triangle. And you can see, if you remember from the first part, this denotes a right angle, the little square. Alright, so how do we find out this value here of this angle? It's very simple. You add the 50 degrees from this angle to the 90 degrees of this angle, and that gives you 140. You take 140 away from 180, and that tells you this angle must be 40 degrees. Let's have a look at another couple of triangles. This one here is the acute triangle. This means that the three angles within the triangle are less than 90 degrees. And you can see, again, if you add these two together, 82 and 61, that's 143. You take that away from the 180, and that tells you that this here is 37 degrees. Now let's look at the next triangle. This is a scalene triangle. What that means is all the lengths are different sizes. So therefore the angles are going to be different sizes. But unlike the acute triangle, you've got two acute angles, but you've got one obtuse angle. Alright, so that tells you that's up to 120 degrees, 180 degrees. So how do you work it out? Again, if you add the 25 to the 35, that gives you 60. Take 60 away from 180, and that tells you that this angle here is 120 degrees. And that is the basics of your circle and your angles. And if you can make the connection between angles and circles, then this will stand you in good stead for any question you may have to face in the exam. So I hope that helped, and good luck.